Hi everyone, in this lesson we are going to discuss about calorimetry. So to start things off, I'm going to introduce the three different kinds of questions that you will be discussing in calorimetry. The first one being the calculation for delta H combustion. The second one being the delta H neutralization of an acid plus a base. Or in some cases, I have delta H solution of a dissolution of a certain compound. Alright, so let's take a look at the first case. Basically, we will have a fuel which we will burn and it will warm up this beaker of water over here. Alright, and this is where we calculate the delta HC itself. Okay, so how do we go about calculating this? We need our two standard equations. So in this case, we have this equation of Q is equal to mc delta T. Alright, there's a reason why I wrote this in blue is because this Q is the heat change of water. Alright, the one that absorbs the heat produced by the chemical. Okay, and the other thing that we are looking at is from the reaction, alright, which is the fuel, where we have this equation of delta H is equal to negative Q over N. Alright, so based on this color code, we will know that the point of this equation, alright, is for us to use the value of N from this fuel source itself. Right, so we want the amount of this fuel that we have been using in this case. So for example, if we are using ethanol C2H5OH, okay, we want the amount of C2H5OH for this value of N, whereas delta T is the temperature of this water change, and of course C and M is also the mass and the specific capacity of this solution. Right, so this is the first example, which is our delta HC. Okay, so let's move on to our second example. In our second example, we'll talk about delta H neutralization, where we pour two solutions together. Right, so this is my acid and this is my base. And so what we are going to see is that there would be a change in the temperature in this thermometer. So once again, we are going to bring out our two equations. Q is equal to mc delta T and delta H is equal to negative Q over N. Alright, so how this works is, if we take a look at this Q, alright, it's basically the whole mixture, alright, the whole solution after you mix them together. So that is why this M is actually derived from the volume of the total volume where you add the acid and the base together. So it is the acid plus the base, because this gives us the total volume. So specific capacity is the specific capacity of the solution. Most of the time we'll just use 4.18. Delta T is the temperature recorded from this reaction. Alright, so it's important for us to now identify what this value of N is. Okay, and this value of N is from our equation. So for delta H neutralization, this is our equation, H plus OH minus, which gives you H2O. So we are essentially interested in the amount of water that is produced by the reaction. Alright, because there are certain cases where we have questions such as this: sodium hydroxide plus H2SO4, right, to give us Na2SO4 and 2H2O. Alright, so in such a case, it is very difficult for us to decide which number we should use for this value N over here. So that is why, for simplicity's sake, we will just use the amount of water for this value of N. Okay, and in our last example, we actually have the solubility of a solid. So if I have a beaker of water here, I put the thermometer in and I throw a piece of solid in, alright, let's say sodium chloride. Okay, the standard equations Q is equal to mc delta T, right, refers to the mass of the solution, the heat capacity of the solution, and the temperature change recorded of the solution, whereas delta H is equal to negative Q over N. Alright, in this case, this N refers to the number of moles of NaCl that has been dissolved. right? Because that is what we get from the definition. Okay, so lastly, there are a few more points that I want to point out. Okay, so just take note that this Q and this Q here, they might not be the same value, right? It depends on whether the question tells you about the efficiency of this heat transfer. So the first Q here corresponds to that of the heat gain or heat absorbed or released by the solution. Okay, but the second Q over here talks about the heat absorbed or released from the dissolution process itself. Okay, and one last final pointer, the alright, one last final pointer, this negative sign here, alright, talks about the is talks about the relationship between absorbing and releasing heat. So basically, if we take a look at the first example, this is easier for us to explain. Why there is a negative sign in the second equation here is because the heat absorbed by this solution was given out by this reaction over here. So there's always an inverse relationship because the heat that's given out is absorbed by the surroundings. Alright, so I hope that this video is able to help you understand the different cases of calorimetry and how to tackle these various questions.